Today we will be discussing a predictive analysis of the American Bank of Commerce's international churn rate. The project was carried out by Jonathan, Amin, and Anusha. The growth of a company is heavily dependent on unit economics, which refers to the direct revenues and costs of a particular business. Churn is one aspect of unit economics which negatively impacts the growth of a company, as it refers to the measure of the number of customers who leave the company in a given period of time. The two forms of churn are involuntary and voluntary churn. Involuntary churning refers to members who churn because of customer delinquencies such as payment failures, while voluntary churning refers to a customer actively deciding to end their membership based on the service they received from a particular company. Essentially, it refers to overall customer satisfaction. The purpose of this predictive analysis is to aid American Bank of Commerce, or ABC, with increasing their overall profitability. This will be accomplished through the identification of bank members who show signs of churning. The machine learning objective or task, therefore, is to create and tune 7 classification models to predict whether a customer will churn. The data for this analysis was sourced as a raw CSV from Kaggle. The data did not have any prior pre-processing, and it was initially collected through American Bank of Commerce's records. The initial dataset had 12 features and 10,000 records regarding the general demographics of the bank's customers as well as their involvement in the bank. The first step in pre-processing the data was the initial correction of the variable types. This step was important to ensure that future operations were able to be carried out without any issues. Next, the text-based data such as the variables country or gender, for example, were handled by using the Pandas getDummies function to recode the text-based data into binary categories. All initial text-based columns were then dropped as they were no longer necessary. The following are the independent variables included within the analysis. Credit score is a discrete variable that indicates the bank customer's credit score. The variable age is a discrete variable that indicates the customer's age. The variable tenure is a discrete variable that indicates the amount of years the customer has been at ABC. The variable balance is a continuous variable that indicates the customer's bank balance. The variable product number is a discrete variable that indicates the amount of products per member. The variable estimated salary is a continuous variable that indicates the estimated income per customer. The variable credit card is a binary variable that indicates whether or not a consumer has a credit card with ABC. The variable active member is a binary variable that indicates whether or not a customer is actively putting money into the bank. The variable country France is a binary variable that indicates whether or not a consumer's country of residence is France. The variable country Germany is a binary variable that indicates whether or not a consumer's country of residence is Germany. The variable country Spain is a binary variable that indicates whether or not a consumer's country of residence is Spain. The variable gender is a binary variable that indicates whether a person is male or female. Then the data was split using a random stratified split into 40% training, 35% validation, and 25% testing. The data was split using FastML model development's train, valid, test, split package, with the stratification specified based on the target variable churn. The random stratified split was completed to ensure that the proportions of the target variable churn was proportional within the sets. Next, the numeric variables of credit score, age, tenure, balance, product number, and estimated salary were analyzed for outliers using box plots. Looking at the box plots produced for each of the numeric variables, it is evident that the variables credit score and age have outliers. However, upon further inspection of the outliers in credit score and age, it can be concluded that the values are plausible and indicative of the actual range of credit scores and ages of possible members. Therefore, this data was retained. Then, the numeric variables were analyzed for skewness using histograms. Based on the histograms produced, the variables age and product number had a right-skewed distribution. The variables balance and credit score had a normal distribution, while tenure and estimated salary had a uniform distribution. The skewness of the numeric variables were handled through the use of sklearn preprocessing standard scalar function on the train set, and then this transformation was applied to the validation and test sets. It should be noted that the splitting of the dataset into the training, testing, and validation sets was completed prior to the scaling to ensure that there was no data leakage within the dataset, as this would reduce the reliability of the results from the models. When looking at the bar graph, it is evident that for credit card holders, the majority of credit card holders are non-churners as seen in dark green. The same trend was seen for non-credit card holders. It should be noted, however, when comparing credit card holders with non-credit card holders, it is evident that those with credit cards have a higher chance of churning at 25.3% than those who do not have credit cards at 20.8%. This observation makes intuitive sense, as those with credit cards are likely to make more purchases on credit, leading to credit card debt. In turn, credit card debt will force customers into involuntary churn, where they leave the bank due to their inability to pay back the purchases made. Correspondingly, the relationship between each of the variables was visualized through a correlation heat map. From this heat map, it should be noted that there is no concern of multicollinearity within the variables, as all of the variables had a correlation value less than 0.8.
The first model we try is the logistic regression model. This model gives an accuracy of 81% and a precision of 61% with both the validation and the test sets. The cumulative gains chart of this logistic regression shows that the logistic regression model outperforms a random model. The lift chart reflects the successful performance of the model as well, showing that, for example, if the top 20% of the sample was chosen, the model would gain 1.9 times higher than choosing 20% at random. The second model is naive Bayes model, which gives 82% accuracy scores with both the validation and the test sets. The precision of this model is 59% with the validation set and 58% with the test set. The cumulative gains chart shows that the model outperforms a random model, and the cumulative lift chart shows that if top 20% of samples are chosen, the model would gain 1.9 times higher than choosing top 20% samples at random. The third model is neural network model, which gives 85% accuracy scores with the validation and 86% with the test set. The precision of this model is 69% with the validation set and 72% with the test set. To optimize the predictability of this model, the variables are normalized into a scale of 0 to 1. The cumulative gains chart shows that the model also outperforms a random model, and the cumulative lift chart shows that the top 20% of samples are chosen, the model would gain 2.2 times higher than choosing top 20% samples at random. The fourth model is k-nearest neighbors model. 9 different k values were tried, and it turns out the k value of 9 shows the best performance. At k equals 9, the model gives 84% accuracy score with the validation and 85% with the test set. The precision of this model is 69% with the validation set and 73% with the test set. The cumulative gains chart shows that the model also outperforms a random model, and the cumulative lift chart shows that if top 20% of the samples are chosen, model would gain 2.0 times higher than choosing top 20% at random.
Decision trees are commonly used in classification models since they are simple to use and easy to understand. Therefore, the decision tree algorithm was selected for the modeling phase. The decision tree model was tuned to find optimal parameters. The final parameters selected are as follows: max depth of 7, minimum impurity decrease of 0, minimum samples leaf of 2, and a minimum sample split of 65. The final tuned model yielded an accuracy of 87% and a precision of 68%. Moreover, the cumulative gains chart indicates that the model outperforms a random model, while the lift chart gives further insight on how well the model performs. For example, the lift chart indicates that if the top 20% of the sample is chosen, the model will have a gain 2.3 times that amount than choosing 20% at random. Similar to the decision tree, random forest produces predictions that are easily understood and works well with the Bangchurn dataset. Generally, the random forest model provides higher level prediction accuracy over the decision tree algorithm, which makes this another ideal model candidate. Moreover, the random forest model included hyperparameter tuning to ensure optimal results. The final parameters selected are as follows: max depth of 14, minimum samples leaf of 1, minimum sample split of 4, and 60 trees in the forest. Furthermore, the cumulative gain chart shows that the model outperforms a random model, while the lift chart specifies how much gain is achieved by targeting specific deciles. Linear discriminant analysis is a dimensionality reduction technique that can be used to predict customer churn with high computational efficiency. The LDA method is easy to implement and can provide interpretable classification results. Furthermore, the final parameters chosen for the LDA model included a least squares solution, LSQR, for the solver with a shrinkage of 0. The model acquired an accuracy of 81% and a precision of 56%. Moreover, the cumulative gain and lift chart indicates the model outperforms a random model with gains at every decile. Accuracy and precision scores of all models used for the study are shown in this table. Each model achieves an accuracy between 80 and 90%, which is most likely due to the imbalanced dataset. Therefore, the precision score will be focused more than accuracy score when determining the best model. From the table, we can see that the random forest model outperformed every model with both the highest accuracy, 87%, and highest precision of 80%. Following the random forest model, the k-nearest neighbor and neural network models had the second and third highest precision scores of 72% and 73%. Despite also being a tree-based model like the random forest, the decision tree yielded a significantly lower precision of 68%. Lastly, logistic regression, naive Bayes, and linear discriminant analysis also had the lowest precision scores of 61%, 58%, and 57% respectively. The naive Bayes and LDA are more suitable to high-dimensional datasets, while logistic regression is suited more for linearly separable datasets. In addition to determining the accuracy and precision, featured importance was also analyzed for the best model to determine how influential each predictor was to the model. The feature importance plot for the random forest suggests that age was the most important predictor by a significant margin. Product number, balance, estimated salary, and credit score also considerably contributed to the model's prediction. By incorporating a feature importance analysis, banks can effectively prioritize specific customer characteristics in marketing campaigns.
In conclusion, Random Forest model shows the best performance among the 7 models based on accuracy and precision scores. This model can now be used to predict if a customer would likely be churning. Based on the results from the model, American Bank of Commerce, or ABC, can now consider setting up an appropriate marketing strategy to target different customers in proper ways to minimize churning and thus to increase profitabilities.
As of current, American Bank of Commerce, ABC, like many banks, is facing the dilemma of finding ways to retain current members to maintain overall profitability. The key crisis in terms of current members is the rate of churn. Voluntary churn based on customer satisfaction levels is an avoidable loss. Customer satisfaction is key to retaining customers, therefore improving overall revenue can be achieved through the analysis of customers in terms of looking into which attributes are indicative of a customer that has a low churn probability. Through research on bank members, those that are more likely to continue with the bank can be targeted by the marketing team via email campaigns, while those that are high churn risk and lower revenue can be avoided to save money on resource expenses. This will help create a balanced customer base that will allow the bank to optimize its resources and minimize churn. In terms of addressing involuntary churning, the way in which to address it would be to determine which subset of customers are likely to churn and determine if it is profitable to expend resources on those members. In order for the business goal to be achieved, 7 classification models were created to predict customer churn, as well as the specific attributes indicative of those that are predictive to churn.
The classification models that were included are logistic regression, naive Bayes, neural network, k-nearest neighbor, decision tree, random forest, and linear discriminant analysis. From our analysis, we have concluded that the random forest model was the most successful in predicting customer churn. Further analysis shows that age, product, number, balance, salary, and credit score were the most important variables in our model. However, age was the most important out of all variables by a significant margin.
Based on the accuracies and precisions of the 7 models, we chose RF, or Random Forest model, as the best prediction tool to see if a customer would likely churn. Our next action plan would be based on the predicted results from this model. Appropriate marketing and promotion strategies will have to be determined to retain customers. Such strategies include appropriate commercials to target their interests based on their information, such as ages, account balances, credit scores, and etc. Thank you for watching our presentation.